Hey, welcome back to Fat Mama Physics. In this video, we're going to continue with 2.1, what is a power? This is part 2. So in the previous video, you had a basic understanding of how a power works, what's the anatomy of it, and in this video, we are going to look at more examples. And specifically, I am going to focus on a nuance and a specific situation when there is a negative sign involved. What happens with negative signs, etc. In this next section, I want you to notice the difference in these three powers. So that's this guy, this one, and this one. Yes, there are negative signs. And yes, this last one has two. But between the first and the second one, there is a key difference. And yes, there are brackets around the -3 as opposed to not having brackets. These two are different. They do not give you the same thing. Here is why. Now, if we have to write some of these out based off a sentence of a power, this is what they will look like, okay? For A, because the -3 is inside the brackets and then raised to the power 4, the -3 is the base. So I'm going to write -3 in there to signify that that is the base. Now, when this negative sign is outside, or it's not part of the exponent here, this 3 is the base, not -3. Even when this is in brackets, notice that it's the whole -3 to the power 4 that's in brackets. The 4 is not outside of the bracket. So this C case looks just like B, except there's some brackets on the outside of the -3 to the power 4 and a negative sign in front. So here the base of the power is still 3. We're not going to evaluate the power just yet. I want to show us a little bit more of the difference. So let's start off with A. A is -3 to the power 4. So just like what we've been used to is writing out the entire power as a multiplication sentence. This is going to look like -3, and then let's just put in the brackets, times -3. I'll just keep writing the multiplication sign here, and making sure that I write that 4 times, okay? What that looks like on a calculator is you making sure you put in your brackets, you put in your -3, and you close the bracket. I think something got negated, so just making sure that everything is good to go. So there you go. I'm -3 in the brackets, and then I do my exponent, okay? I'm not going to show us the answer just quite yet, because there's something else I want to do. Now, if we just multiply these negatives, my question is, would my final answer be negative, or would it be positive? And how do you know? So, if you said my final answer is going to be positive, you are correct, okay? So the reason why it is positive is because look at how many negatives are being multiplied. If I multiply negative with a negative, I get a positive. Then I multiply positive with this negative, then I'm going to get a negative. And then I multiply by a negative again, that's going to give me a positive again. So if I want to track that, I get a positive here, I get a negative here, then I get a positive again. And therefore, my final answer is positive. So, very interesting. That actually touches on the fact that imagine I didn't have this -3, and if my question was -3 to the power of 3 and not 4, then what would I get? I would just get -3 times -3 times -3 times -3 like this. By the way, whenever I don't write a multiplication sign in between, that just all means multiply. Okay, so then I have 3 negatives. This becomes a positive here, and then finally a negative here in between. So that actually gives me a negative answer. So going from an even exponent to an odd exponent changes the fact that I have a positive or a negative value in the end, assuming my negative sign is inside the brackets before raised to the power of 4. Okay, so that was the first thing I wanted to show us, which in this case is the sign. So then we can go ahead and put this in our calculator to the power of 4, and by and all, it gives us 81. Oh, okay. So that's 3 times 3. This is going to be 9, 27 times 3 again, 81. Okay? Or you can do 3 times 3 is 9, and 3 times 3 is 9 here. 9 times 9 is 81. Okay, so the next up, we have comparing it to this one. So because this negative is on the very outside, then I actually get, this actually looks like this. My base is 3. So I have 3 times itself 4 times. Oopsies. So after I write it out, you might be wondering, then where does my negative sign go? Not like that. Ha 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 ha. So my negative sign is on the outside of my 3 to the power 4. So in fact, that's going to look like this. I have negative 1 here, and then this negative 1 is going to multiply whatever this is here on this other side. So I almost have to do 3 to the power of 4 first, and then apply that negative sign. So this would be 81 times negative 1. And that immediately makes my number negative. Okay? So it almost doesn't matter what the exponent is. My final answer is always going to end up negative. Okay? That's a key difference between having the negative on the outside and having the negative as part of the base. That's a huge difference. Okay? So be very careful of these types of questions. Let's do the rest of the problems that are up here. So I have negative 3 to the power 4. The value of the power we found earlier, this is going to be positive 81. Versus if I have the negative here on the outside, this is going to be negative 81. And then this case is just whatever we did in B, but applying a new negative sign. Okay? Because what that looks like is, after I evaluate everything, this is going to look like negative 81. And with a negative on the outside, that's going to just be 81. Positive 81. Okay? So that's the difference between these. Okay? Let's see if you got it. Let's by doing some examples. So, below are some examples. And maybe what I'll do is, now that you've seen how we did the above examples, let's give you a chance to try A by yourself. So I'm going to offer a chance to pause the video, and I will go over this one when you come back. So, good time to pause the video. Okay, so let me do this one with you. And of course, if you just went through the whole lesson by yourself, you're welcome to do that as well. So here, this is negative 3. And then I'm just going to put brackets instead of writing multiplication every time. Okay? So you know, after multiplying negative 3 5 times, which is an odd exponent, your final answer will be negative. Because here, negative, negative give you positive. This is going to be negative again, positive, and then negative. Okay, final answer is going to be negative. And essentially, 81 times 3 is going to be, I believe, 243. Okay. So there you go, is my final answer for A. Okay, so let's see, what should we do? Let me do maybe... maybe. Okay. Actually, you know what? Now that you've kind of seen that, I'm actually going to give you a chance to try B, C, and D. So, giving you another chance to pause the video now that you've confirmed what A looks like. And then we'll come back for example 2. So, again, you're going to try B, C, and D. Okay? Based off of what you've seen before. Good time to pause the video. Okay, I will go over them. So I have here negative 7 to the power 4. So I have negative 7 in brackets like this. Okay, and after I put in my calculator, I know I'm going to get a positive number. It's always good to predict before putting it in. And because I know it's going to be positive, I'm just going to put in 7 to the power 4. Because I know what I'm going to get is going to be positive anyways. Now I have this one. Negative 4 to the power 3. And it doesn't matter what my what my exponent is. I know my final answer is going to be negative, since this is -1 times 4 3 times. Okay, so just like that. And when I put it into my calculator, since I know this is negative, I just do 4 to the power of 3, which is 16, and 16 times 4 is 64. So -64 here. That maybe looks better. Okay, and last but not least, and again, we know this is a -1 times 6 4 times itself 4 times. Okay, my final answer is going to be negative, so without question. And then, can I do this without in my head? No, I don't feel like it. So 6 to the power of 4. And notice I don't care about putting that negative sign because I know it's going to be negative. 1296. 296. Okay, so here we go. All right, so that was not too bad. Okay, so number 2, example 2 looks a little bit trickier. So I'm going to do maybe example 2, not so much. Maybe I'll do 2A, and then you can do B and C. Okay. All right, so let's do 2 together. I'm going to use brackets just to help you out. So I'm going to have -1 times, and in brackets I have -1. Actually, I'll use bigger brackets just to be clear. And then, so these big brackets are these guys over here, just to be more clear there. And I have 8 inside. 10 eighths inside of the bracket. So that's a lot of eights. Jesus. Do I have to write all of them? Okay, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I'm not doing them next time. Okay, here you go. So, we know for sure, after doing all that, our final answer is going to be positive, because I have -1 and a -1 here. Final answer is going to be positive. And then I can just go ahead and do 8 to the power of 10. Okay? Next time, I'm not going to write it out. Hopefully you get the idea now. Let's just make sure I clear that properly. And I get a big number. That is in the billions. 073. Okay. And 741. And last but not least, 824. Okay, there you go. Okay, so that was A for you. I want you to try B and C. So good time to pause the video. Okay, so I am going to not write that long of a sentence, but instead, I know that this is going to be negative. This is negative, so my final answer is going to be positive. And all I have to do is take 8 to the power of 4, which I don't think I want to do in my head right now. So, whoopsies. This is going to be 4096. Okay, so that's it. That is B. Going on to C. Oh, you're wondering if I need the positive sign? No, it's not necessary, but it's just for myself and for you to recognize that the answer is going to be positive. Same thing with C. C is also going to be positive because of that same exact reason. And if I take 8 to the power of 7, I get another big number. 2,97152. 97152. Yay, there you go. Okay. Awesome. That's it. Come on. One more set of examples. Write each number as a power with base 2. Ooh-hoo-hoo-hoo-hoo. So, I would say at this rate, you can brute force this, because I don't expect you to be able to use radical signs or anything of that like. So, the easiest way is to just, on the bottom, take 2, and then see how many times you need to multiply 2 to get this answer. So that's what it means here. Write each number as a power with base 2. Your basis has to be 2, and you need to fill in the exponent at the top. Same thing here. And of course, they're all going to be different since they're different numbers. So what I like to do is I just write 2 on the bottom, and let's say I multiply by 1, 2. So that's 2 to the power of 2. That's 4, not 8. But if I multiply by another 2, that gives me 8. How many 2's are there? 1, 2, 3. So this is 2 to the power of 3 is going to give me 8. If I multiply by another 2 again, this is going to be 8 times 2, that's 16. So that's 2 to the power of 4 2s, so 2 to the power of 4. If I multiply by another 2, then I get, here was 16, 16 times 2, I get 32, so that's just 2 to the power of 5. That's not too bad. And I guess I did it all for you, because it was all to the power, the base 2, so it just made sense to do that. And there you go. This is 2.1, okay? Well, hopefully that wasn't too long, but hopefully it was broken down to a point where you got everything and can do the practice. So I wish you good luck. Thank you for watching. Fan Mama Physics signing out.